All right, I think we'll go ahead and get started. Good afternoon, everyone. Hope you all enjoyed your lunch today. Um, I'll reintroduce myself again for anyone who doesn't already know me. I am Tyler Stevens. I am with KBR on the EED contract, metadata team product owner, so primarily working with MMT. Also a longtime user and curator of the GCMD keywords. So uh, this session this afternoon, the plan is I kind of want to give some intro and primer to the current state of the keywords, kind of like where we are, how's it going, and kind of go from there, talking about some of the fair related concepts for keywords and how fair the GCMD keywords are, or hopefully we can get to be even more fair. There were some recommendations that came out of that, and then kind of wanted to just use this to kind of then hopefully have a really lively discussion after some of this intro to kind of talk about where we see ourselves now, kind of where we're going, and to kind of start to gather some requirements to get us where we may want to go in the future and what the community wants to see in the future, because there's a lot of talks around ontologies, keywords, other machine learning, AI, and how all that plays a role into this. I've heard a lot of really good talks on that, and I think there's a lot of different people have different opinions about things, so hoping to get that kind of feedback as well during the session this afternoon. So I think most people in this room, scan the audience here, know the GCMD keywords, but I'll give a brief introduction anyway for anybody who's new to the keywords. So I've been working on this project since 2002. The keywords have been around several years earlier than that, well over 25 years. And they've continued to evolve based on feedback from DAX, from users, international agencies. There's a huge contingent that contributes to the GCMD keywords. I think some of them even predate Suite. So we have categories across Earth Science Services, project instruments, platforms. I won't read the entire list. You can see it right there on the bottom of your screen. So those that keyword list continues to evolve. How are the keywords being used? In terms of EOS-DIS enterprise tools, they're the facets that you see on the left-hand side of Earth Data Search, right there. Those come from the GCMD keyword list. Users populate the keywords within their metadata records. They're indexed, they're searched, they're ingested, indexed, and searchable in CMR. I don't have a screenshot here, but for folks who use the MMT, the metadata management tool, when you go in and add science keywords or platform keywords, instrument keywords, or some of the other controlled keyword lists in MMT, those are also pointed to the GCMD keyword list. And users can curate those in their metadata records, and just like directly in CMR, access those. We also have a keyword viewer. So in addition to the actual programmatic API, we also have an interface, and I'll show that here in just a little bit after I go through some of these intro slides. We have a user interface for folks who want to browse the keywords. So you can go to interface and search the keyword. It's not searching any data or anything behind the keywords like Earth Data Search. It's just searching the keyword, getting back the complete keyword hierarchy, the UUID, the keyword, keyword definition reference, and some other provenance information about the keywords. And if you're also interested in getting like the RDF or JSON or an XML representation, you can do that through the interface as well. And as I mentioned, the GCMD keywords are used by numerous organizations and groups, well beyond just NASA EOS-DIS. Other U.S. federal agencies are using the keywords. We have several international organizations across CEOS, which is a contingent of Earth observation data centers from around the world that we work with as part of our international contribution to Earth science. So those communities also use the keywords as well, and also contribute and make recommendations for expanding that list of keywords. And if you go to our website, earthdata.nest.gov, there's a link there at the bottom, and the slides are available on the off the Slido. I'm sorry, off the sketch link there if you want to learn more about the keywords and a full list of different communities that use the keywords. The keywords also have governance model. Several years ago, we kind of formalized that governance model. There's an official ESDIS keyword governance community guide document that outlines the steps for contributing keywords and the process that goes through. Generally, if there are like one-off keyword requests, those are primarily fast-tracked and go through a quick process to get added for users. But if there is a broader set of keywords or keyword changes, those go through more of a formal ESCA review. That's the ESDIS Standards Coordination Office review. One example is about 2 years ago or so, we did a total revamp of the platform keywords. This is based on feedback we got from DAX from users. And we made a lot of recommendations there based on the feedback. And then we put that through a formal ESCA review, got even more great feedback from that. And then once that was complete, then we implemented that within the keyword list. So that full governance document is also available on the GCMD idea, the GCMD.earthdata website as well, if you're more interested to go read that later and see the full details of that governance model. I already touched base on this a little bit, talked about some of the tools that use the keywords, but behind the scenes, we do have that RESTful web service for maintaining the keywords. They're available as SCOS concepts, RDF, JSON, AL, or also as XML in the, and that's representation of the keyword thesaurus for that, for our controlled vocabulary. And we also have an internal tool that we use called Keyword Manager, and that's just the tool that our science team uses to curate that keyword list that eventually becomes public. I kind of want to use this slide here to kind of also spark conversation after this kind of this primer here right now. So when the GCMD keyword started, I mentioned well over 25 years ago, we didn't really have much ontologies. We didn't have much semantic web. We didn't have much of the tool and the technologies that we have now. So at the time, that was just envisioned as keyword taxonomy. You have a hierarchy, narrower, broader keywords. And for the most part, that's kind of where things have stayed. GCMD keyword, as they are today, as I mentioned, they're not considered like a full-blown ontology. Parts of the keyword list have spun off into Suite, and a few others have utilized some of the keywords in other ontologies. But the keyword list as it exists today is more broadly just considered a keyword thesaurus or a taxonomy. So like the one question I want to ask a little bit later is, do we want to take that to the next level? Do we want to evolve the keywords as they are now into more of a, into more of the semantics and the ontology? Some of the structure we have now supports that, but it's not quite at that level yet. So I'd be interested to hear what folks think about that here in a little bit. Right. So talking about FAIR, and I did this based on some of the feedback we got back from an OFAIR assessment. I don't know if anyone from that assessment is here in this room. A couple of the authors I think I saw around ESUP. That's next slide. But talking about FAIR, findable, accessible, interoperable, reusable. We kind of get part of the way there in terms of each of these, and I'm just going to delve into a few of these here at the moment. So in terms of findable, user resolvable identifiers. So every keyword string has a unique UUID. That's shown here in the bullet 2. The end part of that big long string of characters, that's the UUID for the keywords. But one question we've gotten asked: should we have DOIs for the keywords? We don't have DOIs for the keywords now. Hearing a couple no's in the room, shaking heads. that was a question. Interesting to know what people think about that. Accessible. Yes, the keywords are publicly accessible. They're not behind any kind of login or you know, access wall or anything like that. They're easily resolvable, as I mentioned, with the UUID. And when you go to that link shown there, you get the keyword, the definition, the reference, and that provenance information. Some questions that we have gotten from feedback is, do we need a more human readable name in the URL? A machine knows what to do with that URL, but it's not human readable. Some feedback we got has been, should we have the actual keyword name in there instead? I don't know. I'll be interested to see what folks think about that, and if that makes it even more or less fair. Interoperable. I think we're a lot of ways close to that one in terms of being, since the keywords are available, in SCOS and XML, where we're interoperable in that sense. But I think there's more to be done there as well. Reusable. I think we can talk more about that. Like as I mentioned, they're already widely adopted and and used as a community standard. And we have a well-documented API and governance model. Fair recommendation. So to follow up with this, as I mentioned, there was a OFAIR guide, OFAIR working group. They just recently published their guide, a practical guide for open, free, and fair NASA Earth Science data projects white paper. And one part of that white paper, they reviewed the GCMD keywords and made some recommendations. So I'm just listing out the recommendations here. I think these are all of these recommendations, I think, are things that we've heard in the past. So when I saw these recommendations, I wasn't like totally blown away by some of these. I talked to Valerie about these as well a little bit. And I think there's some more discussion about, do we want to follow these recommendations? We probably should for some of them. Others, maybe we have questions about. But the first recommendation was to release the keywords with the formal CCO attribution. This is the remind me, this is the code. I don't know what that means. It's the code collaboratory. Creative Commons, yes. I'm sorry. Creative Commons. There's a formal Creative Commons attribute license, and the recommendation there is to formally release those with that license. When talking to Valerie, I think the broader like everything under as this already, I think, falls under that. So it's likely that the keywords would just already fall under that purview. Oh, and if you want to say something, I have to. Yeah, I know you and I talked about that briefly.
For this one in particular, after a long battle, we did get CC0 added to our ESDIS project data use policy page. We could probably be a lot clearer on that page about including GCMD in the citation guidance. I think that's probably the statement of this recommendation.
All right.
Maybe more questions.
You can ask them now, and also at the end. If you have a burning question on this, then let's go for it. And I only have like 2 more slides, and then the rest of it is open discussion. So there's plenty of time for questions.
Yeah, this is highly related to that one. As you know, I talked to you about several ago and asked about, can we put it into the community ontology repository? And you were reluctant to do that. Maybe this change happened between then and now, but essentially that's what CC plus attribution request means, is you can put it somewhere else, right?
Yeah, so right. So right now we do have the platform and instrument keywords in the core. And yesterday, because I was in your session yesterday, and I was adding the science keywords, but I don't know if it might be because some mismatches, but like the way it's represented as a triple store seems a little bit wonky. So I don't know if that's something with the keywords or what core, or just the way the GCMD keywords are represented as is today.
Yeah, appreciate that. I should say for the listeners, this is John Radio that is agitating for the board. And so, yeah, let's talk offline about that and we can help.
Okay.
Thanks for that.
Yeah, I was going to follow up with you anyway on that at some point this week. All right, I'll continue. So the next recommendation here, utilize GCMD keywords, including their URIs and metadata to describe the data products when it's appropriate to do so. What I think this is getting at here is rather than having because if you look at like the JSON representation of the keywords now in like, for example, UMMC collections, it's actually the actual human readable keyword string. This recommendation here is instead of that, use that URI string. That's also a question, or that's also something that's been on our radar. I think there's a lot of questions about right, what implications that has on CMR, the whole EOS ecosystem, whether that is a good practice. I'm curious if other metadata folks in the community are doing anything like that.
So I can tell you NASA has a group doing that. And that's over in the bio realm where all of their metadata is from an ontology. And so you click on something and you get to the ontological definition, complete with all of its axioms and everything else. So yes, that can be done, has been done, and has been done at NASA.
It should be done.
Great. Yeah, I just don't, yeah, I guess the only follow-up question I have is like, right, like what's the implications of that in in terms of like how we do it now? Does it impact DAX, tooling, things like that, to read that versus to read that string versus reading the actual keyword itself?
I'm not sure I understood that question. Could you try it again?
I know, I'm sorry, that was long-winded. I'm right, like I'm talking about like the way software reads that information now, rather than reading the actual human readable keyword string. I assume it's going to have to read like a UUID string and then go back and find the keyword that matches that.
Well, it should be a link.
Right. Yeah. Yes. A link. Yeah. That whole link string.
And I mean, okay, so this goes back to your, should this be an ontology thing? I mean,
Yeah.
typically what you have is a URI, and that URI is associated with a label like sea ice, which is human readable.
Yep.
As well as a lot of other things like a definition and stuff like that. So what you want to display is the label, which is basically a link. I mean, to get to the rest of the information. So when you click on it, you get to the rest of the information. But anyway, the real problem there is that you still have the whole issue of the same term having multiple UUIDs.
Yes. That's one. Yeah, that's I think I had that on another slide, and that was definitely a topic that we've gotten a lot of that we've gotten some criticism for, and how we deal with that. And I think that is just a from the way that the keywords were curated, through legacy means, over the last 25 years, and we haven't gotten away from that issue.
Yeah, I was gonna say, for that recommendation, you likely want both the URL and the keyword, especially
Okay.
when you're sharing metadata outside of NASA.
Yeah.
You're gonna want the human readable keyword, but there are ways to represent both.
Okay. Gotcha. Yeah. That's what I was thinking too, because it's not just being consumed by NASA. So that's why I'm thinking, like, what other implications does that have in that sense? Good point.
Yeah, Tyler, I just wanted to jump in too and say, what Ruth is talking about, if we stop thinking about words and think about entities or concepts, then the URI is the thing, right? And it's got a bunch of properties, and one of the properties is its name, right? Just like you and I are entities, and one thing is I have a name that's human readable, but that's not the same thing as me. My name and I are not the same thing, right? Right, and also Beth is a 4-letter word and I am not a 4-letter word, right? And so if we stop thinking in terms of keywords and start thinking in terms of objects and concepts that we are representing, we can have, imagine a URI that represents dogs, and I say, look, the English label for that is dog, but the French label is chien, right? The Spanish label is perro, and so, those are all the same thing. And then we can, map synonyms and that sort of thing, but we have
Yeah.
a preferred label. It's not, now we're not, having 10 different words that are all different things. They're just 10 different words that all represent the same thing.
And we have that currently now is like we call alt label
Yes.
in
But if we start
KMS,
thinking more
yeah.
like that, then
Okay.
then I think we might conceptually get to a better understanding of what we're trying to do. So, okay. Tomatoes, right?
All right. Yeah, that's appreciate that. Okay. Going down here, the next recommendation, explore community standards, develop actionable strategies to improve the semantic representation of the vocabularies and support implementation for keywords using ontologies like suite. Yeah, I mean, this gets back to, I think, what we were talking about a few minutes earlier on, like one of the previous slides about how we can evolve, how and could and should we evolve the keywords to be more of a true ontology, different than the way they are currently. And that's part of the conversation here today. So yeah, so I mean, I think that is my last slide. So I kind of want to, like I said, just have a primer here, and then just I had a couple of questions and stuff on this slide, and that I think I can start with, but I think we've kind of already answered some of these. How can we better utilize UUIDs? There was a question that Ruth and Beth and others mentioned that, yeah, we do have the same keyword under different hierarchies. So we need to be able to address that as well. Yes.
Not to speak with it, of course. But I do think we also have opportunities where we have the same concept, the same idea under different branches. And so we do need to look at what that deduplication effort might be and look like. And maybe we patch it with, synonyms for the time being, but I do think there are some keywords out there under different hierarchies that are the same concept. And that's gonna be an effort to detangle.
So the ontologist in me is like, yeah, use an ontology. But I do want to say that I'm looking at these questions and I'm hearing your problems. And I really do think an ontology would help. And I'm not convinced that you need to make a new ontology. You might want to look at seeing if you can't just use suite or use Envo, because I say we, I haven't looked at it in a long time. Ruth is the one that can say we, but mapping between suite and Envo and bringing a lot of suite terms into Envo. And then once you do that, you just get all of those mappings and all of those axiomatic definitions that the entire community of people have been working on for decades. Like you can tap into that. You get a UUID, you get all the mappings and it just comes with with annotating your stuff with an info query, essentially. And that, I mean, that's the beauty of using ontologies. So, yeah, I think, so, okay, yeah, I think you should use an ontology, and I don't necessarily think you have to make your own. So that you don't necessarily have to take on the burden of making it and maintaining it. See if there's one out there that checks 80% of the boxes and then contribute to that one.
Well, yeah, I mean, I don't know if the option, I don't know if, right, I guess that is one option. I was also looked at it from like what it would take to, you know, with the GCMD keywords as it exists today and evolve that into a GCMD key ontology rather than, I mean, if that is a path, you know, if that path makes sense versus, going down the sweet Envo road. I'm not sure, but interesting question about that, Beth.
So I don't know, I looked at Envo a little bit, not a lot, I'm not an expert on it, and so maybe I'm gonna step in it, but it does seem to be full of really complex concepts that I'm not convinced are the ones that we need at NASA. I could be wrong about that, so I'm all for reusing existing definitions and whatnot that are out there, but I do think that there's a movement to have more primitives, to, you know, focus more on primitives and that you can put together, right? So that instead of having long wave outgoing radiative flux at the Earth's surface as the concept, you have multiple things that you can put together to create a complex concept so that we don't go the direction of CF, for example, where, you know, there are so many different labels for aerosol optical because, you know, everybody has their own little tweak to it. So, you know, I don't know what the answer is, what we should be doing. I just think that we want to think really hard about what our needs are, what our metadata schemas look like, and the way people might put together, you know, or search, or the uses that we're going to be putting these two. I'm definitely in the applied ontology camp, and I think that we need to tailor our ontology to our specific use cases. So that might be a different vision than other people would use that.
Hi, this is Pascal Ramchandran, Nasdaq. The way I see the problem is, this technology has existed for a better part of 2 decades now. And every couple of years or so, what happens is there's been sort of new terms thrown in, partly I think driven by how it's marketed. So I've seen descriptions of you know, an ontology as a controlled vocabulary. So, you know, you showed that spectrum from Oberst and McGinnis and the early pioneers. So from a basic list of keywords or a glossary to an ontology, you could have you know, any number of sort of complications that you're able to tackle along the way, to the end point of, you know, having reasoning and, you know, inferencing and all that kind of stuff. So I think it behooves us to clarify how are we defining our terms at the very beginning. Give you another example. I've been trying to find out, I mean, based on how knowledge graphs kind of broke through in 2012 when Google came up with theirs and Facebook came up with theirs. My hunch has always been that an ontology provides a schema for a knowledge graph, but I haven't seen that sort of formally defined in in those words. So bottom line, there's just so many, so much sort of room for interpretation, misinterpretation, and reinterpretation. So I think it'd be really good for us before we venture into this, as in terms of defining what do we mean by a control vocabulary for GCMD. And I think that will at least make sure we are not sort of all over the page as far as these terms are concerned.
Beth again. No, go for it.
Sorry, I'm gonna confess to being really old and to tell you that I was working on this stuff in the 1990s. I worked on the site project for anybody that knows that project. And we were trying to build, one ontology for all things, right? And so, God, I mean, it was not doable. And and I mean, maybe it's still out there. They're still out there, but they ended up having to carve out specific space for specific projects and not, the idea of having this one big ontology that covered everybody's use cases and, ran your house and all that stuff. It didn't work out very well. And so I do want to say, I like what Bhaskar is saying. We want to focus in on what we're trying to do, which is to, describe data, right? Our GCMD keywords, at least the science ones, are for describing our data. And if we confine our thinking to that space and not try to worry about too much else in the start, then we can take our GCMD keywords, I think, and ontologize them in terms of the data that we're trying to describe and not necessarily have to adopt an entire giant corpus of terms that aren't really relevant for us. We can really restrict the ontology, I think, in a way that makes it more manageable for us.
There's also online question from Ruth. I see Ruth has her hand raised.
Yeah, so I don't know that you want to adopt something like ENVO. I think that's way overkill for what NASA's trying to do, which is simple discovery. But simply making, the two UUIDs for sea ice, the definition of which is very simplistic, pertaining to the study of frozen seawater over the ocean surface. That's not sea ice. I'm not sure what that. Yeah, it's hard to tie that word or sea ice to that definition. But in any case, a first very simple step would be simply to get rid of the duplicates. Or make them equivalent to each other. And because quite frankly, if somebody's caring about sea ice, they don't care if they're coming down through the cryosphere path or the oceans path. They just want to know that they want sea ice. And they shouldn't have to go two different directions to get all of it, down the oceans path and down the cryosphere path. So, and any kind of ontology can handle that. I mean, just like, I can be a female and a violinist, sea ice can be under the cryosphere and sea ice can be under the ocean. It's fine. So a first step would simply be to do that. And since that's the level at which Suite is, putting those two things back together would probably be a good thing. Because Suite doesn't go much further than that. And the only reason why they're different, I mean, they used to be the same. The issue is that Suite was not actually maintained for a good long time. And it's just now getting some maintenance back. But at least if you could do that, that would be a good start.
Good point. Thanks, Ruth.
I just have probably a dumb question. What does it mean to say that GCMD keywords will adopt suite ontology.
I think I was looking at that from, can we utilize any part of suite? We've gotten that question, I think, for years, and every couple of years at ESIP and other communities like this, like that question, or the discussion comes up, say, oh, can you just use suite? Can we use part of suite? I don't think that's ever an easy question to answer.
So part of the, sorry, I'll find everybody that delivered my, it's to say. So part of the good thing about Suite is it hasn't been maintained, and it takes a lot of time and effort to maintain Suite. And we've got some newer technologies now. We've got vector embeddings, we've got graph databases, we've got large language models that help us with a lot of the broader search and discovery aspects and use cases that we do use GCMD keywords for. And so we're trying to soul search a little bit and say, hey, like, it's been 25 years, we've been trying to go down this ontology path. It's a really tall mountain, a really heavy boulder. We've got a side path maybe that wasn't there before, that might be here now, that could make our efforts easier and still is productive.
Can you hear me?
Yes.
Yeah, so I'm Edward Clark from Temple University. So we recently got our feet wet with the GCMD. This project that I said from the protocol again forward. And we are using GCMD to those things. We are mining scientific literature and there are certain entities that we are looking at in the environment and use the GCMD to download them. So and I'm not a practical person. I haven't seen an application like in the slides or somebody say application. This is an application. This is a problem that we see with GCMD. I haven't seen. I'd like to see an application because I cannot proceed further because of this issue with GCMD. I can give you mine, but we can talk about offline, and I can give you exactly what the problem we face. But in the slides and conversation. So far, it's been hypothetical discussions. I haven't seen a single application where somebody says, I'm using GCMD now, and I cannot go to this other step of the application because of something in GCMD. So I would like to see, I think that the conversation will be a lot more productive if there will be a list of applications and people say, I'm stuck. And tell me I'm stuck. And if you go to ontologies, so that's the second point that I would like to make is, I don't think we have duplicates. I think that's what you have an sort of an ontology or a graph that is being flattened to a tree. And unavoidably, you have multiple entries, multiple paths. You can convert that to an lattice or a graph, and you avoid the duplicates. What do you do?
I know, I that's one of the follow up what you were saying. I think one of the things you said, you were talking about I think you said it was a little hard to hear, application that use the keywords.
Stop. If I take this to ontology, I'll be unstuck.
Oh, I can't quite hear you. There you go.
Okay, so we do have, we have run into some sticking points with our web unification efforts, where having that flattened tree and having those different paths is causing them problems in terms of being able to just discover things. But if we do adopt a graph, if we do adopt, some other method to make those synonyms clearer, to make sure that they're the same thing with different paths to it. Not quite sure which the technological solution to make that happen is, but that's been causing some problems on us lately.
I just want two things. One, responding to your first point, there are, if I'm not mistaken, a whole lot of applications in NASA and elsewhere that have already used and embedded GCMD, and so it has a very large existing user basis the only point they're making there. Obviously, if you're going to move beyond it, you have to do the mappings from it to the new thing. And so that's all. The other concern I had was about the comment that we've tried ontologies that, I'm going to shorten it here, perhaps inappropriately. We've tried ontologies and they're too hard, so let's try something else. I don't understand that at multiple levels, because I know that the suite work, which was cited as an example of something that's been really hard to maintain, I don't believe that's fair. I believe it's fair to say no one chose to maintain it for an extended period of time. And then, since then, it's been upgraded in a number of significant ways, almost entirely by volunteers, with some funded projects, if I'm not mistaken. And so the technology of ontologies here is not the problem. I'm pretty clear on that. These other technologies that are mentioned are potentially valuable additions to the process, tools that can use the ontologies, etc. But no time soon will any of those new technologies replace ontologies as the solution to how to keep track of GCMD keywords.
Beth had her hand up again.
Yeah, just talking about applications too, I mean, I think the issue for us isn't who's using them or how should we use them so much as we don't achieve semantic consistency in applications, and so automation is becoming a problem, discovery is a problem. We need to be able to describe data in a semantically consistent way, and so that we can have improved precision in discovery, but also talking about, future applications. We want to think about those. Machine learning, for example, needs labeled data sets, and those labels need to be consistent. And so I do think that, the fundamental issue we need to solve here is semantic consistency. Ruth is right, starting with deduplication, if that's a real problem. And then the applications will use it, whether it be GCMD keywords or some ontology or something, but we have to get the consistency amongst ourselves, within NASA before I think we start worrying about whether we're consistent with others.
Thanks, Beth. I want to amplify the point that I heard Beth making, which is talking about your question number 5. So are keywords use necessary at all? My answer to that is a resounding yes, because one of the things that we're starting to see is machine learning creating things that then are used for machine learning, and that's just perpetuating garbage, if I want to use a polite word. And I think that this kind of labeling of data and realizing that machine learning can be an assistant to the curation, but that judgment is required. Yes, we have challenges because we have human beings doing it. We have 12 docs doing things 24 different ways.
Yep.
But moving towards that and using some of the tooling to help address the duplication and maybe even convey some of the nuance. Okay, yes, understood Ruth's point that keyword of CI is coming through different paths. On the one hand is a problem, but it can also be of a benefit to recognizing that I'm interested in cryospheric data, and that includes CIs. That if you're just, looking at the keyword one way or another, without recognizing that hierarchy matters. So we're having a Beth Bruce conversation.
Yeah, no, I just wanted to step in there real quick, Bruce, because I put that question 5 up there because I have talked to some people who aren't curators, who aren't into ontologies, just strictly looking at it from a technology perspective and saying, why do we need keywords? You know, vector embeddings or machine learning or AI could potentially do what keywords have done and do it better and get better results. And like, everyone I've talked to have basically said, yeah, I mean, you still need both. We're not there yet. They both can be complementary to each other or aid each other, but we're not anywhere near ready to just
Assume AI is someplace between a toddler and a smart intern. You never use, I said, assume that AI is someplace between a toddler and a smart intern, but you never use it in production.
yeah.
Yeah, and I just wanted to throw in here that, you know, for me, the end goal that we're really trying to move toward is automation. And so, you know, if we're talking about labeling data sets in a semantically consistent way, the reason that we want to be able to do that is for starters, so that, you know, if I say tomato and you say tomato, you know what I meant, right? You know what or if you're, you know, so all of these different labels that you might put on it can map to one another. And I think that's the value an ontology brings for starters, but also so that the machines, if you have, you know, a network of models, for example, that want to talk to each other, one is outputting something and one needs that output for its input. And being able to hand those off, or Doug, you know, Doug Newman, always talking about smart handoffs, or he used to, I don't know, maybe he's lost his enthusiasm, but, you know, if we're gonna get to smart handoffs, then the machines need to know what does this mean? So the video I was.
Oh, I saw heard some feedback.
Okay, sorry. If we're gonna get to that, then the machines need to know what the other machines are talking about, and they need to understand the words that they're using, and that's what ontologies can do for us, that I think GCMD keywords currently aren't doing for us. And, you know, even if you have, so Bruce was talking about cryosphere and sea ice. Sea ice is sea ice, right? It's part of some cryospheric data, right, or of interest to the cryosphere. It's also of interest to hydrologists and other, you know, other groups. And so that's why we don't want to isolate it under cryosphere. I think you can slap that label on it, but it should be separate from the concept sea ice.
Yeah, I think we're all talking the same thing, that we have the two-dimensional vocabulary tree, we need to
Yeah.
make it a three-dimensional.
Yeah.
Tree, whether we do that through graph database, whether we do that through Postgres vector enabled database, but some other way to make those
There's
synonymous connections truly either the same thing or identify the synonyms.
Yeah, my name is Justin Reed. I just wanted to mention this because this is kind of a bit of an area of my expertise, and I've done a little bit of machine. I've done, thanks to people like Paul and you and others, where I've actually done a little bit of this type of work using cosine similarities for the GCMD keywords. And with generative AI specifically and everything, the work that I actually did with GCMD has actually helped me prepare for work with generative AI. With things like vector databases and everything is all based around the same ideas, like the cosine similarity scores and providing context with stuff like this. Where I think that with GCMD keywords and everything, it would probably be a little bit more involved. Like the value is still there with these contexts and embeddings and stuff. It's just what would really have to be done is that we would have to create a vector database with a representation of these GCMD keywords. And with graph databases like, here's like an example like Pinecone or something, you can add that additional context to it and represent it as a database. And how custom generative AI chatbots and searches are actually made is using something called retrieval augmented generation. And there's also like a semantic search semantic search is actually how you would create those specific chatbots and custom search and everything. So I really think that next step into vector databases and adding semantic search using these GCMD keywords is the next step.
I would definitely like to see some more of I would definitely like to talk to you more about your research. It sounds very interesting. Yeah, I have to touch base.
Okay. see a new slide up, are we moving on?
No, I just pulled up the no, I'm done with the slides. I was pulling up the meeting chat to see if what was happening in the meeting chat. Oh, is that what it is? Oh, okay. Yeah, it seemed a little okay, I see what I see. Yeah, that's not a slide, it's it was just a meeting chat.
Yes.
My name is Charlie Burris. I'm with LNCEI, and we use the NASA GCMD Coopers a lot in our metadata. And so I would just say that you guys are already doing this, making it available in multiple formats. But if you move to the ontology sphere, I would say just continue to make it available for those that maybe aren't, for customers that are not necessarily ready for that, but would like to dabble in it.
It's all Ruth is
Yeah, I just
Oh,
want to
raising her
clarify.
hand.
Yeah, I just want to clarify that when I'm talking about single UUIDs, I'm not talking about disconnecting the sea ice from both oceans and the cryosphere. It needs to be connected to both oceans and the cryosphere, but it doesn't need to be two different UUIDs. You know, that's that I was trying to respond to the point that keywords through different paths is a problem, but can be a benefit to recognize related things, which was one of Bruce's points. And that's very true. The issue is that what you really don't like is the idea that there are two different things that are called sea ice that a machine is never going to be able to put back together again, simply because they have two different UUIDs. And so you end up with this bifurcation of the world where maybe some data is under the sea ice in the oceans and some data is under the sea ice in the cryosphere. But unless you've labeled it with both, which then is a duplication of effort, they're never going to come together. And the odds of a hydrologist knowing, oh, I need to put the word cryosphere in there is smaller than if there was only one sea ice.
Ruth, you make an excellent point. I think the unique identifiers we have in GCMD currently are unique identifiers for the path to that keyword concept, as opposed to the unique identifier for that individual concept itself.
Yeah, and like I said, that goes that also, like I said, is it also an artifact of the early days of the keywords when they weren't really being consumed by machines, and you had the oceanographer saying, I want it under that path, but then you had the the other community say, I want it under, I also want it under this path as well, because if I'm an oceanographer, I'm not going to look at it under cryosphere, and then vice versa. That was one of the initial use cases for why we had it under both of those separate paths at that time. Yeah. Yeah.
So from the point of view of GCMDs, what do you?
I'm sorry, I can't hear unless it's off.
Okay, so is the lack of relationships. It's so then they take you to ontologies. So what you have is financial relationship that is syntactic. These terms under these other terms.
Yep, the hierarchical terms. Yeah.
So as I said, we are using GCMD for annotating scientific literature. So patterns we notice, so we find two terms that appear in GCMD, and then we are left, we appear in the same sentence or paragraph, or even in the entire text. What is the relationship between them? And we are doing work on that, and we have some result. But I think that is, if you translate this into two ontologies, that's what you get. Once you have the pairs, either by inference or by being specific, defined very implicitly or implicitly, that's what you may get. Now currently that's visual seeing applications, so in our case, that is missing, that relations. And we are doing some more there, we do like some literature mining, and are able to find words between, that to me is like missing piece. And you have no relations, all is part and child.
Yeah, I mean, we do have some capabilities of relationships, and right now there's not really any tooling or it's really being utilized. So like one example is we do have relationships between platforms and instruments to say, right, these instruments are on this platform. And if you're searching for Aqua Terra, then you want to get back instruments that are on that platform because that might be something you're interested in. We can do those relationships now, as I mentioned, in the keywords in the KMS and represent that, but they're not really being used. I think we had set that up for maybe potentially that being used, but that aspect never really took off.
Yeah, I wanted to just mention too that the GCMD keywords are used as values in metadata records. Or, you know, the and bar, for example, will be hopefully using these keywords in specific relationships to data. What did I measure? What quantity of that thing did I measure? What context was the measurement made in? And that's where the relationships are likely, some of the more specific relationships can be specified because you don't always know, right? What's the relationship between sea ice and this other thing? I don't know, it depends, right? And so metadata records can do that work.
And I know you're not going on too much about it being widely used, but this idea of tying in something like a platform to an instrument and saying like, oh, well, this is it. I don't think we necessarily really want to go down that path if we're talking about all massive data, because I mean, ADAC with airborne and field observations, granted, it's a very small part of the whole like catalog, but it's real easy and it's done all the time where they pull an instrument off a platform and stick it on a different platform. Now,
Yeah.
we can't do that with satellites, but we do have other observations that we want to represent. And if we get stuck on that path, we won't be able to do that well.
You're more representative. But I do think that we should be utilizing our relationship capability more, and I think we should not have platforms and instruments be related, but I think maybe we need different relationships or more relationship options.
It needs to be nimble enough to show that they might vary.
Yes, to be nimble enough to show that it might vary.
Hi, I'm Teddy Gilbert. I'm actually working on the web unification, so forgive me. But what we were talking about just now is that I didn't start it. I just started. But I think what's kind of missing is that a parent-child relationship is not one-to-one, it is one-to-many, and that's what we already do on the site. So for any sensor you find, you'll find all its parents, meaning all its platforms. And I think, you know, obviously flattening it in a way, I don't like that term, but getting rid of duplicates is the goal, ultimately, no matter how we do it. But doing it with an ontology which allows for any view towards any object, any entity, to be valid from different views. So if someone does go in, because Ruth was talking about, you know, the PIs aren't always going to know about all the different paths to one term, and they shouldn't need to. They should just pick the one that they know. We'll know that that term goes to different fields, and we'll have mapped that. So Ruth's using sea ice. I like icebergs better because I think there's 4 icebergs. There's one on the terrestrial hydrosphere too. So all someone needs to know is iceberg. And when they get there, they'll see that there's terrestrial hydrosphere, there's cryosphere, and there's also ocean. But that's not the important part. The important part is they have all the information that's available about icebergs. So yeah, it's a many to many, in fact, because you can have a mother, you can have a father, you can have a stepfather, you know, and so all of those relationships for parent-child have to be kept and reported. And I'm just thinking if, you know, we go to Sweet and animate a great suggestion, but if we go to Sweet, and go, you know, we're gonna have to remap all the data sets we have to those, and there's no need for that. We have UIDs or UIDs tied to them already. So let's utilize that and just make that a characteristic of the entity iceberg. So you go from that UID to iceberg, and then from there you see all its other relationships.
So Teddy, two follow-up things. The first one is iceberg shows up 4 times. I think you said 4, so you're correct. I'm just pulled up our keyword viewer here, and then you mentioned about the platform interrelationships. Are you? You said like you know from the instrument what platform. Are you putting that from GCMD keywords, or how is WebU or what you're doing? How are you getting that information? I'm sorry, I should have told Valerie to get hold the mic view for a second.
So over the course of a year, I went and looked them all up and marked them down in the CMS. That's how we're getting it. We're not getting it from any other way. And then every time a sensor that's on an airborne, I go and try to find all the planes it was on and add them to the page. So
That's manual.
Yeah, that's why you hire a librarian.
Yay.
Yay.
I do wanna just comment though that I think we need to be really careful about overburdening a taxonomy. And assuming that we can all guess what that parent-child relationship is supposed to mean, because it can be a real mess, right? We conflate the subclass relationship with the class membership relationship when we do this, if we're not gonna let ourselves go full-blown ontology and we're gonna confine ourselves to just a taxonomy. And then, you know, we're having, you know, the relationship between an instrument and the platform it's on is not a subclass relationship, and it's also not a class membership relationship. And so there's a third, you know, way that somebody has to guess, and machines can't guess that stuff. We humans might figure it out, but if we're, you know, again, I'm looking for automation in the future, and I don't want us to get stuck, you know, in the 1990s. And then go, oh, dang it, you know, if only we'd done this more robustly, we would be able to do this automation now.
So I think the answer to that and the goal is ultimately your parent doesn't matter. It doesn't matter. We know you like icebergs, so we'll show you everything that we have on icebergs. It doesn't matter if you're an oceanographer, if you're coming through cryosphere. It shouldn't really matter. We record it just so it's easier to browse into it. It's easier to search. It's easier for PIs, they just have to pick one. But we record it, we do the hard work, and we give you everything there is to give you on icebergs. Again, sorry, with the labor on that example, but yeah.
So returning to the difficulty question that I commented on earlier, of going to ontologies. I want to say that GCMD is the accumulation of an insane amount of knowledge and work over 25 years now, more.
Yep.
And it has both extremely high value, and you can feel how it's getting pulled in all of these different directions as far as its complexity and the desire to have it do more things and different things and be even more sophisticated. And it's true to say that managing it as an ontology or as any other kind of sophisticated entity, knowledge graph or something else, is going to be complex. It's a rich undertaking for a rich knowledge source. And I think a fair number of people in the room who would like to see it migrate to that state, in addition to forcing the clarification of all the existing hidden and not so hidden relationships and confusions, are eager to see it be capable of supporting the more sophisticated requirements that are implicit in the way people are trying to use it and tag it and work with it. So this is a bit of a plea to the higher level management, even above the GCMD management, but at NASA, at the other organizations. You'll hear it again in Brandon's workshop session Friday morning, that all of these organizations have to accept that they're dealing with complex things, and they should bloody well spend the money to deal with them correctly, rather than keeping pushing that down to the individual projects with not enough money to do it themselves.
That's why Valerie's in the room.
So this is more of a question for you, Valerie, and or Tyler. Anytime you deal with semantic technologies, you know, you have to come up with how are you sort of querying the semantically enabled metadata. For instance, are you ending up with like a Sparkle endpoints, or you know, in other words, how do you foresee users querying an interactive database of sorts, or it could even be, you know, API or other ways? So do you have a sense for that right now? Because that'll change a whole lot based on, because we've never dealt with semantic technology before. So seeing how users might be using this will probably drive how this evolves.
We haven't had a whole lot of success in it yet.
I mean, I was gonna say in terms of technologies, one that has come up is the graph database. I don't know if Ryan Abbott's on the call. He's the architect in our train, and that's one thing he was considering, like using, you know, the graph database, graph technology, because right now it's just a relational database. As I mentioned, it's pretty old as it is now. So that was one of the type of database we were that was on the table. Obviously, that's not, you know, there's other alternatives out there, but that was just one.
Yeah, we.
One.
I was gonna say, I think we're gonna come out of this knowing that we need to do a feature analysis on whether we should pursue vector embedded database or a graph database of some sort. What the pros and cons of either of those technical solutions might be. Our current relational database, I think, it needs to evolve.
I mean, it has its limitations as it is today. Yeah.
But there are a couple options, and so we need to delve into what the benefits of each are and what their cons are.
And if there are others, like, you know, I was gonna say, if there are others, you know, besides a couple that we just talked about, we're all ears to put them on the table in terms of, you know, going down that path.
Postgres and graph DB.
I don't have any other slides. It was just kind of I think it's just been some really interesting discussion and looking at some of the technology, some of the inputs. I think yeah, as Valerie said, we're already starting to get a lot of information from this discussion to take back and talk about doing a feature analysis or a white paper or something. Oh, there's another question over there.
Big mouth. I just wanted to know if
Oh, people on the line too. Thank you. Appreciate it.
I just wanted to know if you all had considered Neo4j technology, graph technology.
we'll take a look at Neo4j in addition to our existing knowledge graph. Not sure what the underlying technology of our current graph instance is.
I'm sorry. What was that, Valerie? Oh,
Database are you using?
graph, we use GraphQL, but that's not, oh, sorry, like, that's the query language. I have to get back to you on that. I don't know the exact, if Joe wasn't here, he would probably know.
So when you mention graph databases, so they are the end result of representing something that is formally defined, whether it's Neo4j or mapping or whatever else you choose. So I'm still unclear about what it is that you represent in the graph. How do you represent? We have two entities. What is the relationship between them? When you create the triplets, what it is? Is just parent-child relationship? Is it what? That's what I like. What it is that you say? I'll move it to a graph. What would be the relationship between both?
I don't know. So moving it to a graph would be other relationships as well. So it would be making the synonyms possible. So like the iceberg, making it a single iceberg that has these other relationship connections out in the graph. So it's taking that two-dimensional hierarchy and turning it into a three-dimensional.
Well, yeah, I mean,
There's other ways to do that.
yeah, I mean, I think it makes sense to, right, define the use cases, define all the requirements first, and then from there, I you know, see what technologies and databases that can be used to solve those use cases and
Some of that already.
yeah.
For example, you've got relationships.
Yeah, as I'm saying, like we have some of that. Excuse me a second. Yeah, I mean, we have some of that in there. Yes, correct. We have some of that in there currently. Like I said, it's not really being used, but I think other like newer technologies could greatly obviously expand on that. So if we eventually migrate this to GraphDB or some other new technology, we want to make sure we keep that knowledge when we go from this to that.
I think there might be sorry if this is naive, I think there might be an unnecessary concern about how you're managing this data in a piece of hardware versus what the information model content is that you're using for the data. There are a lot of organizations and major enterprises that put their ontology, which is a graph representation, if you like, on GitHub. And then they might have 10 different projects that use the ontology in different ways, and each one spins its own representational database. One of the stores goes on BioPortal, another one goes in another library, another one goes somewhere else. And you're not trying to solve all the representational problems of where it's stored yourself. You just solve the problem of representing the knowledge.
Represent knowledge, then it's served, I guess, and then served out in the ways that each different community needs.
That's right.
Needs it. So maybe like that's the model that the GCMD keywords could be.
It's a model. It's a model to consider because
okay, that's interesting.
It takes you out of the responsibility of thinking ahead of time about all the possible requirements that GCMD will have to fulfill, and focus on just the services that you want to present with GCMD yourself, as opposed to the services that we at Core, BioPortal, or any other project in the universe chooses to present with the same information. So that's the advantage of, I think that's one reason a lot of us keep coming back to ontologies, because at least that's a well-defined representation that we're confident can hold all the information you currently have without losing any information, and that these other systems can all understand.
quick comment here. So yesterday we had a nice conversation and was very wishing made this parallel between ontologies being the sort of the class and knowledge graphs being the instances of that schema. So when you look at GCMD or say ontology, what it is that are the concepts that you have to take it to a higher level, and what is mentioned here, I think it's those individual instances that every community can do whatever they want to, and you are not really that. So yeah.
Oh, we also have Ruth is raising her hand. Are you there, Ruth?
Oh, sorry, forgot to unmute. So I want to re-echo what John said, because that's so very true. You shouldn't try to solve all the problems of the universe. If you may have a information model, you can just make that available and everybody can solve their own problem. But back to that, I guess my question is, what is the suite of use cases that GCMD cares about? Is it really only data discovery? In which case the other parts of FAIR, you know, like interoperability of data, are maybe not in your bailiwick. And the reason why I'm mentioning that is because I've recently read a bunch of papers from people who decided not to use GCMD, but to use Suite because it was an ontology, and then they could label their data that way. And they were doing weird things like, you know, in cities doing, you know, predictions of water main failures and that kind of, you know, sustainability work. But they were having to take data from all sorts of different kinds of things like city infrastructure maps and stuff like that and integrate it with water information. And so they couldn't really use the GCMD keywords that way. But they were using as an ontology to do that work. And so they were merging a bunch of ontologies with parts of Suite and stuff like that. So I guess that's my question is, what is the mission of the GCMD? Because that'll really determine what those use cases are and how far you need to go in terms of improving the GCMD representation as it currently exists.
So that's a really interesting and good question, but I just want to say, I don't think that discovery is the only use case that we have. It's an important one, of course, but you know, providing, I mean, there are multiple things here too. We've got so much data. We use GCMD keywords to describe our data. And, you know, we might even want to automate the process of describing our data, and the ontology can do some work in the form of inference rules that will help us generate automatic labels based on some input that we might get from somewhere else, whether it be a human or from another system or something. But also, you know, eventually we do want to be able to automate services. We've got data discovery. Our UMM-BAR working group came up with data discovery, variable level data discovery, subsetting, regridding, resampling, something else, visualization, right? So we've got all of these things that need to be supported by the metadata that currently GCMD keywords are used to provide values in for some metadata elements. I think the more you can glean from the values that are put in there, which may be provided by an ontology, the better off you're going to be later on trying to satisfy those kinds of use cases.
Yeah, this is Valerie. I'll just add, I think our primary use case for GCMD is to have that control vocabulary, that getting rid of the ambiguity about what you're talking about. It enables search and discovery. It enables a lot of other uses, but its primary purpose is to be that source of what this entity is, what this concept is, what it means, and where it fits with other entities. And I think we have some ironing out to do in terms of those other relationships, right? We do have some duplication, and we have some non-duplication. It looks like it might be, right? Same term in different tree branches that aren't really rendering the same thing. And so there's some trickiness there when we talk about duplication. But that is the core and use case of GCMD is having that definitive, this is what this concept means, and in relation to these other concepts.
Yeah, if I could add a concrete example, I'm imagining a universe in which we have an ontology and instruments. You know, I've got an instrument that might be the value of a metadata field on a metadata record, and that instrument has a bunch of information about it, and a data analysis, sorry, a data, I'm so loud, I'm always worried that
You're good.
A data analysis system down the road somewhere is able to make use of the instrument information by reading the metadata record, knowing that it's an in situ instrument or something like that, and is able to actually work that into, you know, maybe the algorithm takes that information and does a different kind of analysis, or, you know, knows something that helps in the analysis. So I think that's the kind of work that eventually we'd like the use of GCMD keywords to do, that you can go around in this graph from one piece of information to another piece of information, and all of that information can then be brought to bear on whatever task it is you're trying to do with our data.
Yeah.
I think we might be running close to time. You all said one.
Yeah, we got like 5 minutes or so if anyone has any final burning questions.
I just have one question about it. Do we, I know we probably do, haven't paid any attention to this because of other reasons, but I assume the end goal is a semantically enabled GCMD. So do we have, I'm sure you have a set of requirements that are driving all this, right? If you do, it'll be really nice to see what those are, so that I have a clear understanding of, okay, these are things that are in the near and long term.
We don't have the clear set of requirements. It would be beneficial to have those. It would also be beneficial to get broader project prioritization of this. I mean,
Yeah, I was gonna say we have, the follow up note, we have some ideas, we have some loose things, but yeah.
In suggestion, you mentioned white paper, it may be worth to create a community of interest for this project, to work together, get the requirements, get some application that you mentioned earlier as examples, and go from there and build the rest. And after that, and when it becomes a white paper, then the community gets you get feedback, you iterate a few times, and then you go into the work. Just a suggestion.
Or I wonder if it's Valerie, if it's like I don't know if people go far to say as like a ESDSWG working group, or is that overkill?
Overkill or underkill.
Well,
Yeah.
I mean, I didn't want us to sort of camp and take over the sweet for not sweet words, but that would be, it would be good to have that community. I also don't think it's still writing white paper after white paper after white paper. I really want to just get to the crux of what's really hurting us, which seems to be that intermixed relationships, that the fact that our unique identifiers are currently the path to the keyword instead of the actual concept of the keyword. And I think if we can iron that out, I think it'll make a lot of our pain go away. There's a lot of different ways we could do that, but I think that's the crux of the problem that's ailing us. And maybe we get, you know, do some preliminary analysis and then pull in the community and say, hey, can we work on a prototype of this or that, and get some feedback in that way. But I don't want to just get stuck in white paper either.
An information. That's what.
And a hack fest going.
Any last goes for conversations? Otherwise, I will give you all my great thanks.
Yeah,
Good job.
yeah, appreciate the conversation. We had some good discussion here. Yeah, thank you all.